Good day to you all again. Evan Stamen here for 1.11 Making a Difference. Today we are going to continue with our revision of grade 11 coordinate geometry or analytical geometry in preparation for the matric work. Again, all the questions that I've seen from matric exams have a large emphasis on the grade 11 work, so please take this seriously. We are now going to revise the idea of parallel and perpendicular lines and the idea of gradient. The first we need to remember is that parallel lines are lines that go off in the same direction. And so it should not be a surprise to you that parallel lines have got the same gradients. So if I was to take a parallel line and run it over here, badly drawn, so let me try that with a better option. And I was to try that over here, and I was to ask you for the equation of that red line parallel to the blue line with the equation y equals 2x minus 3, but going through the point 1.7. Because these lines are going off in the same direction, okay, so parallel lines are going off in the same direction, it's no surprise that this leads to the idea that they've got equal gradient. Now, we know there's a straight line, and so because it is a straight line, we know that it's going to be a case of y equals mx plus c. However, I want to emphasize something which I'm sure that you know, but I just want to make it very explicit, that when we are doing y equals mx plus c, our goal is find m, find c. Sometimes, not often, you can find c before you find m, but more often than not, you're finding m before you find c. Now, in some cases, you're finding that m value through the gradient of 2 points, but in this case, we're going to use the idea of parallel lines to find the gradient. So we know from here that the gradient of the blue line is 2. What separates these two things is whereas the blue line has got a y-cut or y-intercept of minus 3, so that is its c value. That is not the case for the red graph. The red graph c value is what separates these two functions from one another. So we're going to find m using some information, and we're going to find c using some information. So we now know that because these things are parallel, that the m of the gradient of the blue line, which is 2, is the same as the gradient of the red line. We write down y equals 2x plus c, confusing myself with the similar sounding words, 2x plus c, and then we sub in the point that we know that lies on that line. So in this case, 1 and 7. And we're going to get 7 equals 2 times 1 plus c, and as a result 5 equals c. Please note how here we've achieved goal 1, and here we've now achieved goal 2. What I'm trying to do is create a system for you by which we do the same thing pretty much every single time. And so it becomes second nature to do this routine over and over and over again. So please also don't forget to actually make sure that you answer the question. There's no point in doing all this hard work and not getting the full marks for actually answering the question. The equation to this thing would now be y equals 2x plus 5. Now I know there are others of you who prefer a slightly different formula and you don't like the formula y equals mx plus c, or you may be taught by your teachers a slightly different formula. Ultimately, it's the same idea. Okay, there's not a major difference between the two techniques. It's just effectively when you substitute and how c pops out of the substitution. Okay, so again, parallel lines go off in the same direction and they have therefore got the same gradients. We are trying to find m, and then we are trying to find c, goal 1 and goal 2, and we are trying to set up a same routine for all types of questions of this nature. Now, when it comes to perpendicular lines, which is our next option, I want to quickly show you something which I find to be quite fun. If we had a piece of paper, and a piece of paper tends to be, for example, let's say with A4 paper. A4 paper is in the proportion 7:10. Now, that means that if I was to take a piece of paper and to draw a diagonal line across the page, that this line would have the gradient of 10/7. Okay? However, if I was to take this page and I was to rotate it 90 degrees, okay, such that this page was now lying in the, I suppose we'd call it now the landscape position, if you're familiar with such terms, okay, that red line would now have the line coming from top left to bottom right. Whereas the 10 used to be the vertical component, it is now the horizontal component. And whereas the 7 used to be the horizontal component, it is now the vertical component. You can also see that this graph was increasing. It was heading upwards, whereas this graph is heading downwards, what we used to call an increasing function versus a decreasing function. I don't think it is too difficult to realize that this second graph now has got a gradient of -7/10. Now, I know that the formula says that officially m1 times m2 equals -1. And we can use that formula with the greatest pleasure. But I think what's a lot more intuitive to see is the relationship between this fraction, 10/7, and this fraction, -7/10. And we very often refer to these things as being negative reciprocals. Now, if I was to ask any of my pupils what is a reciprocal, they would put two fingers out in front of them and they would flip, and they would show some sort of rotational idea of a flip, that the top had become the bottom and the bottom had become the top. I'm quite happy with that. Okay. Now, it's the idea that's important here, not necessarily the use or the reliance on the formula. So lines that are perpendicular to one another have gradients that are officially negative reciprocals. Alternatively, they have a product that is -1. They're the negative flip of one another. So if the one was positive, the other is negative. Vice versa, if the first one was negative, the other one would be positive, and they would be the negative reciprocal of one another. Now, strangely, sometimes when things are easier, they actually end up appearing to be a little bit harder. So what happens here, again, quickly, let me make a copy of this page, and let's go for it. Okay, so now what happens is, surprisingly, sometimes when things are slightly easier, they may actually appear slightly more difficult, because understanding the idea of a flip of 7/10 becoming 10/7, and the negative reciprocal becoming -10/7, what do I do when my first thing has a gradient of 2? How can I do the reciprocal of 2 when 2 isn't a fraction? And again, this is why matric work is sometimes a little bit complicated, because there's so much that you need to remember from the junior grades. All you need to remember is that 2 is simply 2/1. Okay? So if I now write that m is 2/1, then the gradient of the first line is 2/1, which means that the gradient of the perpendicular will be what? Okay, what does this mean about the gradient of the perpendicular? This means that the gradient of the perpendicular line will need to be minus, flip it, 1/2. Okay, so the gradient of the second line is -1/2. Buying into what we said just now, we have gone and achieved goal 1. We have found m. Okay, so again, find m, find c. Okay, we have achieved goal 1. Now we're going to go and achieve goal 2. Goal 2 requires me to find c, and we're going to do the exact same thing we did last time, which is to find the value of c by substitution. So we're going to take this, we're going to rewrite it as we had just now. Y equals -1/2x plus c. We're going to substitute in the value 1 or the values 1 and 7. So 7 equals minus a half x. So minus a half x plus c. I've made it. Okay, again, we are substituting not only for y, but we're also substituting in for x. So we know that x is going to be 1. We can take that across and realize that 15 over 2 equals c. And so I now have a formula of y equals minus a half x plus 15 over 2. And then again, don't be surprised if in some questions in exams they ask you to rewrite it in other forms. So I would have 2y equals minus x plus 15. And so they very often ask you to write it as x plus 2y minus 15 equals 0. And this is simply an alternate form of writing an equation. Please don't forget that this here is what we call standard form. So again, standard form is this version, and the alternate form is this version. Okay, so we've been able to find quite quickly that using the same basic ideas and techniques, which I think is a much more efficient way to do things, to use the same technique for different types of questions, is helping us here to find the equations of lines. Okay, so again, we know there's a straight line, so y equals mx plus c. So we find m, and then we find c. Okay, so again, I just want to quickly make it explicit here, that over here, we've solved for goal number 2. We found c. Okay, what I now need to look at is this idea of the angle of inclination. And again, if you look at your trigonometry, you know that if I had a triangle in standard form, and I had theta over there, that theta was opposite over adjacent. So tan of theta equaled opposite over adjacent. But considering that these lines are in standard position, then this is the change in y and this is the change in x. So tan of theta is the change in y over the change in x. So we saw that in grade 11, we were able to see that tan theta was the same as m, or that those two ideas were interchangeable. But again, if you were taught that a gradient was a similar notion to the direction in which the line was traveling, the steepness of the graph, or the, Afrikaans, die helling van die grafiek, then this idea of the gradient being linked to the angle at which this graph is rising or falling, then that sort of makes sense. So again, given that that is our background to this idea that m equals tan theta, then I want to make a point with you that this gradient is true all the way along the line, because it is a straight line. So the gradient remains a constant everywhere along the line. As a result, this angle that it is making with the horizontal is the angle that it's making with the horizontal anywhere on the line. So it is not only over here that the gradient is going to be theta, for example. If I had a horizontal line higher up, that would be theta. If I had a horizontal line lower down, that would be theta. It is going to be theta everywhere in the graph. Now, again, I think this leads us to a very easy way to understand how to solve this sort of problem. If m equals tan theta, again, and we are being asked to find the coordinates of, for example, let's say this point A, B, C. And so we're being asked to find the size of this angle over here, the angle that lies between these two lines, blue and green. Then what I'm suggesting is that the easiest way to do this is to actually draw a horizontal line, or draw a horizontal emanating from, I'm going to redo that because it just looks slightly untidy, to do it with our horizontal line emanating from the vertex of the angle that we are required to find. Now, when we do this, we know that on the blue line, clearly from here, we can see that the gradient is 2. So on the blue line, the gradient is 2. So 2 equals tan of theta. So arctan or shift tan or tan to the minus 1 of 2 in degrees. Please make sure that your calculator is on degrees. Will give you theta. And again, if I've done this correctly, I should be able to see that therefore theta equals 63,4 degrees. Now please remember, that is the angle that this line is making with the horizontal. So that component, not the whole orange thing, but from the horizontal line to the line is 63,4 degrees. I can, if something works, let's keep doing it. For the green line, we can see that the gradient is minus a third. So when I go to the calculator and say tan to the minus 1, arctan of minus a third equals theta. We could call it any other letter we wanted to, but just for the moment, let's leave it as theta. Okay, we get an answer of, again, sorry for quickly having a look, minus 18.4 degrees. Okay, so we get an answer of minus 18.4 degrees equals theta. Now, I know that that is not the official answer, but it does help us in this question to realize that if a positive angle is going upwards, that a negative angle is going downwards. So this is 18.4 degrees. I do know that that officially, therefore, the angle of inclination will be 161.4 degrees, 161.6 degrees equals theta, because remember, the definition for an angle of inclination is that theta needs to be between 0 and 180 degrees. So officially we can't get negative angles of inclination, but ultimately it's the same concept. We can work our way through that. Okay? So instead of seeing it as being the angle from the horizontal all the way over to the line, we can see it as just being the angle from the horizontal downwards to the line. Well, if the one is 63.4 and the other one is 18.4, then I don't think it's going to be too much of a stretch to expect a matric kid to realize that all I need to do here is add them. So the angle here, ABC, will equal 63.4 plus 18.4 and get an answer of, I don't know, something 0.8, 71, 81.8 is what I'm getting. Cool. Now, that's what happens when these two things are going off in, well, one's increasing, one's decreasing. One of the gradients is positive and one of the gradients is negative. Somehow, students seem to find the other one to be a little bit more complicated, so I've got an example of that here for us. But we're going to do the same thing. Okay? The only difference here is now my horizontal line is going to be in green because I've chosen to use different colors this time. So if I put my horizontal line in over here, there's my horizontal line. Okay, we can see it's parallel to the x-axis, so we can see that as a horizontal line. Okay, we're going to do pretty much the same thing for the blue line. M equals 2, therefore arctan of 2 equals theta, so theta equals 63.4 degrees. That is the angle between the horizontal and that line there, 63.4 degrees. However, in the case of the red line, we've got that M equals 7. So arctan, tan to the minus 1, shift tan, however your teacher chooses to teach it to you, is theta. And we therefore get that theta equals 81.9 degrees. Again, that is that movement. Okay, from the horizontal up to the line. So that's 81.9. How big then is the angle between these two lines? Okay, again, how big then is this angle? Let's call it A, B, C. How big is the angle between these two lines? How big is that angle over there? Okay, well, it's simply going to be, instead of adding the two values, in this case, I'm going to subtract the two values. So what I'm going to get here is that theta, in this case, therefore, ABC is going to equal 81.9 minus 63.4. And again, I don't have a calculator with me, so I do apologize if I get this, if I make a slight error. I'm getting 18.5 degrees. Okay, cool. So what I need to do quickly is look at this last example. Calculate the gradient of AB. This again is coming from an old textbook. Not difficult to see that, again, the change in x and the change in y. The change in x is from -5 across to, the change in x is from -5 across to 4, so it's got a change of 9. The change in y is from -3 up to 12, or from 12 down to -3, which is 15. So my gradient here, 4.1, my gradient of AB is going to be 15 over 9, which is 5 over 3. Question 2, 4.2, determine the coordinates of point E. Okay, so again, having read it, okay, it intersects the x-axis at E, so E is a x-cut, and we know that to find an x-cut you need to make y equal to 0, but you need the equation of the line first, so again, you find the equation of a line, so y equals mx plus c, y equals 5 over 3x plus c. You're going to sub in either point. You could do a, but then your values are negatives. So I'm going to choose to sub in the point 4 and 12. So 12 equals 5 over 3 times 4 plus c. So 12 equals 20 over 3 plus c. 12 is 36 thirds. So 16 over 3 equals c. I've got an answer of y equals 5 thirds x plus 16 over 3. To find a x-cut, I need to make y naught. So naught equals 5 over 3x plus 16 over 3. And as a result, x equals minus 16 over 5. So the coordinates, again, please note they've asked you for coordinates. E's coordinates would be minus 16 over 5 and naught. Okay, determine the size of A. This is exactly what we've been talking about, so we can go through that quite quickly. Therefore, 4.3 alpha would be arctan of 5 over 3, which is going to equal 59 degrees. So we know that alpha over here is 59 degrees. They now tell us for the next part of the question that theta at the top here is 76 degrees. And then I ask us to find the equation of the line through A parallel to BC. Lovely question as I've mixed through all the various ideas in one question. So let's have a look here. Okay, so we're looking for the line that is parallel to BC, but traveling through A. So we know that if these lines are parallel, they've got the same gradient. Well, if this angle was known, I could find the gradient. But if these things are set 59 and 76 degrees, then I know that this angle here must be 45 degrees by 3 angles of a triangle. So I know that the gradient of BC, okay, so quickly, 4.4. So the gradient of BC would be arctan. So not arctan, I've actually got the angle. I'm trying to find the value. So if that's 45 degrees, that's 135 degrees. Would be tan of 135 degrees, which is minus 1. So the gradient of the parallel line will be minus 1. We've done the same thing as before. We've achieved goal 1. Find m. You're going to sub in the point, so y equals minus 1x plus c. We sub in the point that we know that's on that thing, so it's minus 5 and minus 3. And we get y equals, not y equals because we're subbing in, apologies quickly. and we get an answer of minus 5 equals minus 1 times minus 3 plus c, so minus 8 equals c. And as a result, y equals minus 5/3 x minus 8. And we are done. Okay, thank you very much for your time. We'll now move on to the next video shortly. Hope you can join us. Thank you.